Bismillah ar-Rahman ar-Rahim. This is Dr. Ahmad Al Faris. Today we are going to answer Mechanics M1 for January 2021. Okay. Now, as we know that usually in the last years, because of the new syllabus, there's 7-8 questions, and these questions usually the first 2-3 questions they are warm-up questions, they are easy questions, and they start to make them the questions hard after the question number 6 or starting from question number 6. Usually they bring 1 or 2 questions about vectors, one question about that, one question about moment, one question about momentum, one question about equilibrium objects, one question about inclined plane, okay, one question about pulleys and how the object it will move. Now, sometimes they mix ideas there, pulleys with inclined planes or pulleys with equilibrium object or horizontal surface plane. So sometimes they mix ideas, but other times, usually the questions are easy. Okay. Now, in the last 2 years, okay, we can see that the level of the questions, they start to be higher. That's why the grade boundaries becomes lower. Okay. For example, the first question here, what do we have? A stone is projected vertically upwards with a speed of 20. This is u. Okay, from point of O, which is 5 meters, okay, above the horizontal ground. The stone is modeled as a particle under free gravity. Okay, find the speed v, okay, when the stone at an instant of 2 meters above the ground. Now let's draw what we have here. We have this point O, it's on this level, which is 5 meters above the ground. So the distance from here to here is 5 meters. It's moved under gravity, so it's projected with the initial speed of u. It moves upward, reach the maximum height, then fall where downwards. They say that they wanted the height of 2 meters above the ground. That means the total displacement from where it started, from here, to where it finished here, it's what? -3. The displacement is -3 meters. So according to that, what are the information that we have? So it's -3, u, it's 20, and it's positive because it's upwards. V, I don't have it. Okay, they ask about it. Acceleration, it's of course -9.8, and the time they don't ask about it. So what is the formula that I'm going to use, okay, without that doesn't have a time, okay, to find the v? It's what? V square equal u square plus 2as. Okay, is my voice clear? Okay, okay, good. Now let's continue. So v square equal u square plus 2as. Now they ask about v, so v equals square root of u, which is 20, okay, square plus 2 times -9.8 multiplied by what? -3, because the displacement is -3. And by using the calculator, the answer will be 21.4 meters per second, okay? Or you can write it as 2 significant figure, 21 meters per second, okay? This is the first 2 marks question. It's easy. Next part here, part B, what do they ask? They ask the total time between the instant when the stone is projected from O, okay, and the instant when it first strikes with the ground, okay? So according to what do we have here, okay, who's F here? Okay, I'll, if you please get out and turn in with your name, if you please, okay? Thank you. Okay. So in part B, what do we have here? Okay, they ask about the total time from the instant which is projected from O, okay, here, to the instant that it reached where? To the ground here. So I'm going to use that, okay, again. And what are the information? S is the total displacement, which is -5, okay. U, it's still 20, okay. V, they didn't ask about it, okay. They ask about the total time, this one. And the acceleration is still -9.8. Okay, so I'm going to use the equation that doesn't have v, okay, which is s equal ut plus half a t squared. Okay, now in this situation, the displacement, which is -5, equal u, which is 20 t, plus half times -9.8 multiplied by what? T squared. By using quadratic equation, I will get that 4.9 t squared minus 20 t minus 5, which is equal to 0. I have to show them that I'm going to find the value of t by using the equation negative b plus minus square root of b squared minus 4ac divided by 2a. And the values that I can find by using calculator, it's two values. One is negative, I've rejected, or what is positive, and the answer, it will be 4.3, okay, 2 seconds. This is the answer. Or you can write it 4.3 seconds. Good. Is it clear? If you want to take screenshots, you can write it, take a screenshot now. Any question here? Is it clear? Any question? Let's move on to the next question. You can send me on the chat. If you have any problem, you can send me on the chat directly, or you can turn on the microphone. I don't have any problem. Means Annie, I didn't hear. Mean? Okay, type good. Yeah. Let's move on to second question. Here in second question, what do we have? Okay, it's obvious that talks about momentum. Two particles P and Q have masses of 2m and m. Directly, I would say that we have P, okay, we have P, we have Q, okay, and we are going to write m, u, v, impulse, okay, and let's put the values directly in the question. So we have 2m and m. Respectively, the particles are moving towards each other. That means one is positive and the other is negative. Okay. Now, and the velocities here, what do we have it here? Okay, in opposite direction along the same line with on a smooth horizontal plane, the particles collide directly. Immediately before collision, the speed of P was 3u and the speed of Q is 2u. Okay. Now, the magnitude of the impulse exerted on Q by B is what? 5 mu. And it's the same for both. But they said that the magnitude, they said it's what? The magnitude of the impulse. Now we have to be careful. Now, if P is moving to the right, okay, and Q is moving to the left, as they collide, and the moment of collision, that means we have a force from Q on P to the left and from P on Q to the right, action and reaction. So that's why the impulse, okay, on P, it will be negative. But on Q, it will be what? Positive, okay? Again, since P is moving to the right and it's P by Q, which is moving to the left, okay? The force on P, it will be to the left. And the force on Q, the impulse on Q, it will be to the right. That means the impulse on P, it will be to the left, negative, and on Q, it will be to the right, okay? Now, what do they ask? They ask about the speed. After collision, they ask about V for P and V for what? For Q. Now, I'm going to use the same equation twice. It's a very easy question, okay? So, I would say that impulse equal mv minus u for P, okay? And I'll substitute the values, okay? So what are the values here? Okay, the impulse, which is negative 5 mu equal 2m multiplied by v that we want to find it out minus u, which is 3u, okay? And m with m cancel out each other, negative 5u equal 2v minus 6u. Move this negative 6u to the other side, it'll be positive. So it will be U equal to V. That means V for P equal U over 2 or half U. This is the answer for the first part, part A. Now the answer for the second part, part B, I'm going to use the same equation, impulse equal change of momentum, mv minus u, but not for P, for Q, okay? So the impulse on Q, you can see it's 5 mu, which is equal to the mass, which is m, multiplied by V, we want to find it out, minus u, which is negative 2u, don't forget the negative here, okay? So negative will be positive, m with m cancel out each other, 5u equal V plus 2u, move the 2u to the other side, B, it will be equal 3u for whom? For Q, and this is the answer for part what? B. As you can see, it's 6 marks, that means approximately 7.5 minute times, okay? And you can do it in less than 5 minutes, and you can save all this extra time, okay, to the last questions, which needs more time to think about what the steps of doing the question, okay? Any question here? Is it clear? Yes, we can start from the graph here, the table, sorry, and put the information and continue like this. Of course, we can do it in several steps. You can see it on the mark scheme, okay? For example, this one, this question, I did it only in 2 steps. I put the equation, I use the quadratic equation to find the time, or you can do it in 4 steps and you still get the same answer. It's your decision, okay? I'm showing you how to answer it in short time and smart way, and it's your decision which way you are going to use, okay? As usual. Any question? Is it clear?
Yes, it is.
طيب تمام شكرا لك. Let's move on to third question. Question number 3 here. It's about resultant force for an object which is, I think it's in equilibrium. Let's read the question. Okay. Question number 3. A parcel of mass 20 kg is at rest on a rough horizontal floor. The coefficient of friction is 0.3, and this is the mass. Okay. 2 forces, as you can see. Okay, both acting on the same vertical line, okay, of magnitude 200 Newton and T Newton applied on the parcel. That one of them is 200 Newton with an angle of 15 to the horizontal, and the other is T with an angle of 25 to the horizontal as shown in the figure. The parcel mounted as a particle P, okay? Find the smallest value of T which makes P remains what? Equilibrium. That the smallest value. So if I increase T more than this value, it will start to accelerate. Now it's still in equilibrium. Equilibrium may be at rest, maybe at constant velocity, but I think it's at rest, okay? So because they said it's at rest here, okay? So if the force exceeds this value, the word small do not get you confused. If they say that it's an extra force to make it accelerate, that's something else. But they ask about the smallest force, that means this is the maximum force that remains at rest. The maximum force that still this object remains at rest. If we exceed the force, any extra fraction of a Newton, what will happen? It will start accelerating. So you know me, I don't prefer to draw on the same picture, okay? I'll draw the forces. How many forces you can see here? How many forces act on this object? Yes, tell me, how many forces do we have here?
5.
5. What are they? The weight, okay, 20g. This force of 200 Newton with an angle of 15 degrees. Okay, we have another force here of T with an angle of 25. Okay, we have normal reaction. Okay, what's left?
Friction.
Exactly. Now, in which direction do you think the friction will act?
Depends.
The same as the tension.
In the same direction of tension, to the right or to the left? In which direction? This is the trick. When they say the smallest, okay,
so it's the same as the tension because they ask the smallest value of T.
The smallest value of T that remains at equilibrium. So if I move the tension, I exceed it more than this value, it will start to accelerate. That means the friction, it will be where? Okay, it will be in the opposite what? Direction of T, okay? So these are the forces, as you can see. We have okay, 1, 2, 3, 4, 5 forces. I need to resolve them on what? On the smart axes that I told you before, okay? And the smart axes are what? The vertical and the horizontal what? Axes. Each one of these forces, I will resolve them in what? In each dimension. For example, this tension between the up and to the right, that means it will be up, okay? Okay, who is this? Someone came up and sent me a message. Okay.
Mr. Ahmed,
Yes, فضل.
can you repeat again how we came to the conclusion that friction is on the other side?
Okay, they said the smallest value to make it equilibrium. I said in the opposite way. I said the maximum force to keep it at rest. The smallest force to stay in equilibrium, okay, that means it's still at rest. The maximum force until it is at what? At rest. If we exceed the force any fraction, okay, it starts accelerating. In which direction does it accelerate? In the same direction of tension, to the right. So that
Okay,
means,
okay, I get it.
that
I
means
get
the
the trick.
friction, it will be in the opposite what? In the opposite direction, okay? Good.
Okay, thank you very much.
Welcome, you are welcome. Okay, مين هذا صح remove. Okay. في ناس داخلين مش باسمائهم. Okay, so this T, okay, and this T, and we have the normal, okay, here, still, okay, and this 200 force, it will be resolved, one upward 200 and one to the right, okay, hold on, one 200, one, the other is to the left, okay, 200, and also we have the friction force that's still in the left. Okay, we add them together, and don't forget what? The weight which acts downward, 20 G. So it's very important to realize what are the values that I'm going to use. For example, this tension, we have the angle to the horizontal, 25 degrees. So it will be T what here in this direction? T what? T sine or T cosine? T cosine because it's a close, because it's the adjacent. Bravo. So T cosine, the 25, okay? And here it will be T sine.
Why is it T cosine?
Why it's T cosine? Now you need to resolve it into two components that they have the same value as T, right? Okay, so we have this T and this one. One is vertical and one is horizontal. The one which is horizontal to the angle of 25, is it the adjacent or the opposite? It's the adjacent. And we know that if we have the hypotenuse, which is T, okay, that means, okay, cosine the 25 equal the adjacent divided by the hypotenuse. The hypotenuse is the value of T, okay? And sorry, the hypotenuse is T and cosine 25. I need to find what? A is to the right, which is what? The component in the x-axis of what? T. The component of the force. I'll do cross multiplication, so the component on the x-axis, it will be T cosine if I do cross multiplication, okay? Good? Did I answer your question?
Yes.
Okay, I did. I accept her. Okay, I accept Rola to get inside. Okay, so, and R doesn't have any resolving. So here, okay, what about the 200? We have two values, one to the left and one to the right. Okay, so the one in the left, it will be 2 cosine or 2 sine 15?
Cosine.
Cosine 15. And the one on the top, it will be what? Sine what? 15. Okay, so after we do that, okay, what do we have? We have we have three equations here. What are the equations that I have them? Okay, what are the equations that I do have them? Who can tell how many equations I can find? The forces up equal the forces were down. This is the first equation. Also, the forces left is equal to the forces right. This is the second equation. What is the third equation that link this all? Yes,
The
friction.
friction equal mu multiplied by R. When I do these three steps, that's why it's 9 marks question. When I do these three steps, okay, I put the equation together, I get my answer finally. So first of all, forces up equal forces down. So what are the forces up? I have R plus T sine 25 plus 200 sine 15 equal the force downward, which is what? 20 G. So from all of this, I will find R equal 20G, okay, minus T sine 25, okay, minus also 200 sine 15, okay. This is R. This is the first step. Second step, forces left equal forces right. So what I'm going to say, friction plus 200 cosine 15 is equal to T cosine 25. So I'll make F equal T cosine 25 minus 200 cosine 15. I put all this, equation number 1 and equation number 2 in what? And step number 3 in equation number 3. So the friction force, which is T cosine 25 minus 200 cosine 15 equal mu, which is how much? Mu 0.3, 0.3 multiplied by, open a bracket, what? 20G minus T sine 25 minus 200 sine what? 15, close the bracket. Now, what I'm going to do now, it's math, okay? I want to find T. I have T here and I have T here. So what I'm going to do, it's very easy, okay? So T cosine 25, look here. 0.3, I will put it for this one, and this one, okay? So here it will be 0.3 T sine 25, but it's negative sign. I'll move it to the other side. So it will be plus 0.3 what? T sine 25, okay? Equal. Now, 0.3 times 20 times 9.8 minus what? 0.3 times 200 sine 15, okay? Good. This one minus 200 cosine 15, I added to the other side, plus 200 what? Cosine what? 15. Now I need to find T, so T equal all of this. I put all of this over what? Cosine 25 plus 0.3 sine 25. I take T as common factor from both of them and divide by the value, okay, of all of that, and I will get T, and it's supposed to be 192 in Newton, okay? So let me repeat what we did here. Okay, first of all, we draw the free body diagram. Then we choose our smart axes. We resolve all the forces not on the axes. We find the 3 steps formula: forces up equal forces down, forces left equal forces right, and friction equal mu R. We find how much is R. We find how much is F. We substitute it in the last equation and we continue math. Please don't do any mistake and do that because it takes a long time. I know that. And this is the final answer. That's why it takes 9 marks. 9 marks is approximately 12 minutes, okay? So you can do it, okay, if you understand that, if you know how to draw this, okay? You can do that in less than 10 minutes, okay? Good. If you please take a screenshot here.
All right, give me a second.
Take another screenshot here, okay? I put the whole thing in one page, okay? Good. You can send me any question or anything that is not clear on the chat. Clear directly. I will repeat it. Yeah. Repeat if you please, or what, or how you get this, or how you get that. Any question? It's directly. I can find out the answer. Okay. I can explain it again. شكرا للشباب اللي عم تاخذ سكرين شوت وعم تبعت على الجروب. Thank you a lot. Okay. Let's move on to question number 3. Question number 3. It's about moment. Okay. 6 marks, 7.5 minutes. Look, what do we have? We have a girder, okay, that's supported by C and D, 1 meter, 1 meter, and it's 6 meters long. Okay, a metal girder, okay, AB has a weight of W Newton and length of 6 meters. It is rest on horizontal two positions, okay, C and D, 1 meter, 1 meter, as shown in the figure. When the force of magnitude 900 Newton acts on A upwards, it starts to tilt about C. What that means? Who can tell me? Who can remind me when I said it's about to tilt or tilt to about D? What that means? That means there is no what?
D equals 0.
D equals 0 for what? There is no what? There's no normal. There is no normal. Exactly. There is no normal action at C, and this is the smartest way you can answer the question quickly. Right. This is the first information. The second information: when a force of magnitude 1,500 Newton applied at B, okay, this one upward, okay, it starts to tilt about what? About C. That means there is no normal reaction at D at this moment. Okay. This is the smart way we can answer the question. We are going to use, okay, 3 equations in this one. Equation for here, and equation forces up equal forces down. Not necessarily. Let's see what we're going to do. Okay, the girder, okay, is modeled as non-uniform, okay, rod, okay, whose center of mass is a distance x away from what? Away from A. Find the value of what? Of x. Easy. I'm going to draw this, okay, my own drawing twice, okay, and I will make 2 equations. And I'll substitute these 2 equations into each other to find out the answer. But first of all, we have to know that in the first situation, the forces up equal forces down is not the same as the second equation, forces up equal forces down. They are not the same at all. Okay, there are 2 different equations, 2 different situations. Okay, so first one, look here. This is the rod. Okay, what do we have? When there is a force of 900 Newton applied upwards, okay, at here, this is 900 Newton. Okay. It starts to tilt about D. That means there's a force from D upwards. We don't know how much it is. And we have the weight of it, W, okay. Unknown, acts somewhere away from what? Away from A by a distance of how much? X, like this. So when they say tilting about D, I'm going to choose D as what? As a pivot. Now, if I know that the whole distance is 6 meters, that means, okay, the distance from here to here is 1 meter, and the distance from here to here is 5 meters. So how much left between D and the weight W? How much is the distance here? Yes, thank you. On your, you send me on the chat. It's 5 minus X. The distance between D and the weight W, okay, which is X meter away from A, it will be 5, the whole distance from D to A, okay, minus X, exactly. So what I'm going to do here, this is the first equation, first situation. I'm going to start about whom? About D, moment clockwise equal moment anti-clockwise. So what is the moment clockwise here? And what is the moment anti-clockwise? The moment clockwise that we have it here, okay, it's from the 900 Newton. So 900 Newton multiplied by its distance equal the weight W multiplied by its what distance. So the 900 Newton multiplied by the distance, which is 5, okay, equal the distance W multiplied by what? 5 minus X, okay. So this is the first equation, which is 4,500 Newton equal 5W minus XW. Okay, this is equation number 1. Now, in the second situation, what do we have here? When the force of magnitude 1,500 Newton applied at B, okay, let's draw it. So the same drawing here, okay. This is B, 500 Newton acts upward here, 1,500 Newton. It starts to what? It's okay, it's tilt about C. Okay, that means there's no D anymore. There's D here, there's C, sorry. Okay, and the weight still acting what? Down. So what are the distances that we have it here? We have the distance from B to C, which is 5 meters. The distance from C to A, which is 1 meter. Okay. And the distance from W to C is how much? Because we know that the whole distance here from here to here, it's X. Okay, so that means it will be X minus 1. Okay, the distance between C and W. So this is the first step. Second step, I'm going to start about whom? About C, because they tilt about C. So about C, moment clockwise is equal moment anti-clockwise. So who act clockwise? The force W, the weight, and anti-clockwise the 1,500 Newton, okay, from B. So let's substitute W, okay, multiplied by its distance is equal to the 1,500 multiplied by its distance. So W multiplied by the distance, which is X minus 1. Okay, and 1,500 multiplied by the whole distance about C, here about D, okay, which is 5. So here it will be 7,500 is equal to XW minus W. This is equation number what? Equation number 2. Now, if we add these two equations, it's obvious that we have minus XW plus XW, they cancel out each other, right? So adding this third step, adding equation number 1 plus equation number 2, what do we have here? Okay, so 7,500 plus 4,500 is equal to 5W minus W, and minus XW plus XW, they cancel out each other. So here 4W is equal to 15,000. Sorry, not 15. 4 plus 3, it's 11, 12. 12,000. Okay. So divide by 4, divide by 4. W equal 3,000. Right? In Newton. مظبوط الحسبة 4 و7 11. Yes, correct. Okay. Now I will do in what? I'll substitute, for example, in equation number 2. In equation number 2, okay, X multiplied by 3,000 minus 3,000 is equal to 7,500. So move this to the other side. 10,500 is equal to 3,000 X divided by 3,000 divided by 3,000. How much it will be X? It will be 3.5. So X equal 3.5 meter. Okay. This is the whole answer. Okay, you can take a screenshot and send it. Clear? Any question? I'm looking to the watch. Okay, you can see that we are doing these questions very fast. Okay, we are now in 36 minutes and we did 4 huge questions actually. Okay, fine. Let's move on. Let's move on to question number 5. Okay. Question number 5, 7 marks on it. Okay. What do we have here? A particle is acted upon 2 forces, F and G. The force F, okay, has a magnitude of 80 Newton and acts in the direction of bearing 240. Again, when they say bearing of 240, 90, 180, 240, it's in this direction and it's 80 Newton. This is the force F, okay? Tamam? So here the angle is 60 degrees left, okay? And G has a magnitude of 10 Newton and acts due south, okay? So we have 2 forces here. Force F of magnitude 8 and force what? What? Force G of magnitude what? 10 and acts downward vertically, okay? given that R equal F plus G, now we know that G, it's acting here. If you draw it as his head-tail drawing, it will be like this. And the same thing for the force F, it will be like this. We have a parallelogram, okay? And in this parallelogram, okay, you can see that the resultant, it will be in the middle, okay, from here to here, okay? This is the resultant, okay? And the angle between F, the angle between F and G, it's what, 60 degrees. Or this angle, it's how much? 120 degrees. If the external angle is what, 60 degrees. Find the magnitude of R and given the direction, okay, the direction of R, give your answer as bearing. Yani I need to find this, okay, this angle, and I will add it to to the bearing of how much? 180 to make the whole thing from the north, right? Okay, now I have a triangle here, okay, that I know two sides of it and the angle between them. So which formula I'll use? Tell me on the chat, which rule I'll use. I'll not do resolving here, okay? I'll use something directly in one step.
Cosine rule.
Cosine rule, excellent, bravo. Shukran, shukran, shukran. So what I'm going to say, R square equal F square plus G square. Okay, you can do it in two different ways. You can say plus 2f G cosine the angle, which is 60, the external angle, okay, if you said plus, or you can say minus if you said 120, the angle between them. Yeah, so it's your decision. Or you can say F square plus 8 square minus 2FG cosine what? 120. In both situations, okay, my answer, it will be R equal square root of 8 square plus 10 square minus 2 times 8 times 10, okay, cosine 120. And the answer, it will be square root of 244, which is equal to 15.6 Newton. Good. This is the part I. Take a screenshot for that. This is part I. Is it clear?
Yes, it is.
طيب
بس
شكرا.
بنفع من المطالع نصير نعمل ريكورد.
أنا عامل ريكورد.
والله؟ اوكي. كويس.
اوكي. يلكم.
شكرا.
You are welcome. Okay. Next, double I. They ask for the angle theta, but they ask it as bearing. Okay. So theta, I'll use sine rule to find theta. So I know that this angle is 120 and the opposite of it. Okay. And I want to find theta. So what I'm going to say, I'm going to say sine theta divided by the opposite, which is F. Okay. Equal sine 120 divided by R, okay, and by doing cross multiplication and find theta equal sine inverse of what? Of F, which is 8 sine 120 over square root of 244. And by using calculator, it will be how much? It will be 26 degrees. So the bearing, it will be 180 plus 26, which it will be 206 degrees. This part double I. You can take a screenshot for this. Okay. This is theta, this is 120, this is R, and this is F. This is G. Good.
استاذ في مجال تعيد هذا البارت لانه ما انتبهتش.
Which part?
Part B, part II.
Double I. We have a triangle here. As you can see, we have a triangle here. Okay. And this triangle I rewrote here. That this is the resultant. Okay. This is G, which is 10. Okay. And this is the force F, which is 8. And I want to find angle theta. Now, we know that according to sine rule, sine theta over the opposite, which is F, equal sine the 120 degrees over R. Okay, we
خلاص
find
تمام.
R. Good.
تمام.
Then we added as bearing because this direction starts from here and this is the north. This is 180 degrees. I need to the whole angle until what? Until here. Good.
تمام. شكرا أستاذ.
You are welcome. Let's move on to next question. Question number 6. It's about vectors here. Oh, I remember this question. Okay, Bismillah. Two girls, Agathi and Pironi, oh, forget the names, A and B, okay, are rules, okay, on skating inside a large empty building, okay. The girls are moving as particles. At time equals 0, okay, A has a position vector of 11i plus 11j, okay, and B has a position vector of 7i plus 16j, okay. The position vectors of are given relative to the point O, R, and J are the perpendicular vectors. One is to the east and one to the north. A skis with a constant velocity. They give us the velocity of A, and B with the constant velocity. So actually, what do we have here? They give us the R naught for A, which is 11I plus 11J, and the R naught for B, which is what? 7I plus what? 16J. And they give us what? The velocity for A, which is 3I minus J, and the velocity for whom? For B, which is what? 4I minus 2J. These are the information that they give it to us so far, right? Okay. Now, this is at t equals 0. Okay. What they ask here. Find the position vector, okay, for A in time equal t0. Now, it's very easy. R equal R naught plus Vt, which is equal to 11I plus 11J plus velocity, which is 3I minus J, all between brackets in terms of T. You can keep it like this. We get the 2 marks, or you can rearrange it to make it 11 minus 3Ti plus 11 minus what? Tj, which is better. Okay, I'm going to use it later on. This is easy 2 marks. At t equals 6 seconds, okay, A passes through the point P. Show that B also passes B, and find, okay, 2 questions, and find the time, okay, when it occurs. Okay, now we have to substitute for A, the time 6 seconds. I already have it, okay? So R at t equal 6, that's part B, equal what? 11 minus 6, 3 times 6 over I. I'm substituting on this equation, okay? Plus 11 minus what? 6 multiplied by J, which is what? Okay, 3 times 6, 18, 11 minus 18, which is negative 7i, okay, plus 11 minus 6, which is what? 5j. This is the position for whom? For P. This is the position vector for P, the point P, okay, the point P. Now, this is the first step. Second step, I will show them that B passes through this point. Okay, after how long? They will see that. So look here. B, we know that R for B is equal to what? We add these together. Okay, 7 plus 4Ti plus 16 minus 2Tj. This is the position vector for B. Now I will make this, okay, equal the position vector for P, okay, which is what? 7T, okay, 7 and negative 7I plus what? 5J. That means because it passes through this point, okay, that means the I's and the J's, the value of it, if I substitute the value of T in both of them, they have to be what? Equal. So that means 7 plus 4T is equal to negative 7. Okay, and also the 16 minus 2t supposed to be equal what? 5, right? Right? Is it clear so far? Okay. There's something wrong here.
أستاذ
Okay.
مش ب A لازم تكون 11 plus 3t مش minus 3t.
11 plus 3. I'm sorry. Yes.
Part
11
A.
plus 3t. Okay. So the whole answer is wrong here. Yes. Okay. Okay. Thank you for fixing this. So 11 plus, I copied it wrong. Okay. Plus. So here it will be 29. Yes. 29. So here it will be 29. Yes. My mistake. Okay. So 29, by using the calculator, okay, the t is supposed to be in both sides the same. So minus 7, it will be 22 equal 4t. So t equal divide by 4, it's 4.5 seconds. Okay, here the same thing. Move the t to the other side, and negative 11 equal negative 2.5 divided by 2, it will be, I'm sorry, 5.5. T equal 5.5 seconds. And this one, okay, is 5.5 seconds. Good. So yes, after how long? 5.5 seconds. Good. This is part B. Then what they said, at time t seconds, A is at a point A and B is a point B. Show that AB is equal to this value. AB, as you know that, okay, that's part C. AB means what? Means R for B minus R for A, right? So we have to put it in order, both of these equations, to get this value, R of B minus R for whom? For A. Now, R for B, we just wrote it here, okay? Okay, so I'll write it down. So 7 plus 4ti plus 16 minus 2tj. All of this, I put negative in front of it, okay? And I'm sorry, this is for B. Okay, I'll put B minus what? A. So it will be 7 plus 4ti minus, plus, sorry, 16 minus 2tj minus, open a bracket, for A. What's for A? It's 11 plus 3t, 11 plus 3ti plus 11 minus tj, 11 minus tj. Okay, so 7 minus 11 is how much? How much 7 minus 11 is negative 4. Plus 4t minus 3t, it's t. Plus 16 minus 11, it's 5. Minus 2t minus t, it will be minus t, so it will be plus t, so it will be minus tj. This is the same as they give it to us, but in different order. T minus 4i plus 4 minus t what? J. That's what we have. Now, when they give us this, they give us that. Why they give it to us? Because we need to use it in part D. So, alhamdulillah, they give it to us. Okay, it's for us, it's easy, 2 marks. Okay. Now, what they ask after this? Any questions so far? Is it clear so far? Okay, take a screenshot if you please. If you want, take a screenshot. Okay. Now, what they ask? Find the distance between the 2 girls when they are closest together. Okay, now we're talking about math here. When they are closest to each other, okay, and they ask about the distance and find out the distance. Now, the distance is it's the magnitude of this value, right? So when we said about displacement, this is A, B, okay? Now, when we talk about displacement here, so that means d squared is equal to what? T minus 4 squared plus 5 minus t squared. Now, they ask about the smallest distance here. So d squared equal, yes, t squared minus 8, t plus 16. If I did a mistake, tell me, okay? Plus 25 minus 10 t, okay, plus t squared. Right so far? Is it good? Okay, now let's rearrange it. 2t squared minus 18 t plus 41. This is d squared. And since they say that it's the closest, and you know that we're talking about a graph here between what? XY axis, something like this. Okay, it's a quadratic equation. And this is, they ask about this closest, that they ask about this smallest distance from here to here. They ask about the what? The differentiation of this one. So if I do delta d over delta t, okay, that means it will be 4t, okay, minus 18, okay, and this is the closest distance supposed to be equal to what? 0. That means 4t minus 18 is equal to 0. So 4t equal 18. So t equal what? 4.5, right? 4.5 seconds. This will, the time will be the shortest or the smallest distance, this part D of this question. It's math, don't forget that, okay? Good? Clear? Take a screenshot if you please. Any question? Okay.
أستاذ
Yes, تفضلي.
مش هو سأل عن ال shortest distance فمش المفروض نعمل substitute للتايم بالoriginal equation.
Do we have the time?
مش طلعنا 4.5.
Ah, yes, I'm sorry. Sorry, I forget that. So this is the first step. This is the second step. أنا آسف يا هبة. Third step, okay, the distance, okay, in this way, distance, I'll put it in this equation here, okay. Then I'll make the magnitude, okay, so it's 4.5 minus what? Minus 4, all I, plus what? 5 minus 4.5 j, okay. So here it will be half I plus half j. So the magnitude of d, the fourth step, equal half square plus half square under square root, which will be square root of half, right? Which is 0.71 meter. Thank you, Hiba. I find the time when they are closed. Okay. This is the answer here for part D. Take screenshot. As you can see, it's long, okay? And they put only how many marks? 4 marks on it. So if you can't do it, you'll not lose that much marks, okay, on the total. Good. Any question? Okay, let's move on to next question. Question number 7. Okay, yeah, and this question. What do we have? Helicopter. A helicopter is hovering at rest above a horizontal ground at point H, at the point H. A parachutist steps out of the helicopter and immediately falls vertically and freely under gravity, fall down, okay, with the gravity acceleration from rest for 2.5 seconds. His parachute then opens and causes him to immediately decelerate at constant deceleration of, this is negative 3.9 meters per second square. For how long? T seconds, where T is less than 6 seconds. Okay. Until his speed is reduced to V. Okay. So this is U for initial step of what? Of acceleration. Then there's deceleration, second step, until it reaches the velocity V. Okay. He then moves with this constant speed V. Okay. Until what? He reaches the ground or hits the ground. While he is decelerating, okay, he falls a distance of how much? 73.75 meters, and the total time of the, okay, between the instant that he leaves H, okay, the helicopter H, okay, and the instant when he reached the ground is how long? 20 seconds, okay? The parachute is modeling as particle A. Find the speed of the particle at the instant we open the parachute. Now, we have to know that we have saw that here. So we know that U is 0. They ask about V, and the acceleration is 9.8, and the duration for that is 2.5 seconds. So V equal U plus 80, which is equal to 0 plus 9.8 multiplied by 2.5, and it will be what? 24.5 meters per second. Now this is speed, final speed of acceleration. It will be initial speed for deceleration, okay? It will be initial speed for deceleration. Part B, sketch the speed time graph for the motion of the parachutist from the instant that he leaves H to the instant that he hits the ground. Okay, so we know that in part B, what do we have? We're going to draw what? Velocity or speed, meters per second, time graph in seconds for his motion. Now, his motion, it has 3 parts. First part, acceleration from rest to the speed of how much? 24.5. Then what? Then deceleration. Okay, the deceleration has a time t, which is less than 6 seconds. So from here to here, there was deceleration, constant deceleration for time t. And don't forget that the acceleration was for only 2.5 seconds. Okay, and when he reached the velocity v, okay, here, okay, he stops accelerating and move with a steady speed, okay, like this until he reaches the ground at what? 20 seconds. Okay, that's what happens here. So they give us information that what? Okay, when he is what? Decelerating, he falls a distance of 73.75 meters. So this area, this distance here, to find the time, okay, from here to here, okay, it was 73.75 meters. Okay, the area here, okay, it was like this. Okay, the distance was this area. Okay. Now we sketch the speed time graph. Okay. Now what do they ask here? Okay, we sketch the speed time graph until this moment, which is 20 seconds. Okay, find the value of t, 5 marks. Then find to the nearest meter the height. Okay, it's easy. Now we have to find how much is the value of t. We know that. Okay, distance is equal to what, ya shabab? To area. And what this shape looks like? This is trapezium, right? Trapezium. Okay. Now we have A, we have B, and we have what? H, the height H. Okay. Now the distance, which is 73.75, it's equal to A plus B over 2 multiplied by what? By the height, what? H. Now, we don't know the value V, but what do we have? Informations. That's why they put 5 marks. We know that the deceleration here It has a value of what? Negative what? Negative 3.9. So here it's negative 3.9, the deceleration. So also we know that acceleration equal v minus u over what? Over t. So the acceleration, which is negative 3.9, is equal to v, the unknown v, okay, minus u, which is 24.5, divided by capital T. And here we know that A is what? The whole height here is first base is 24.5 plus the second base, which is V, over what? Over 2 multiplied by what? By the height, which is what? T. Now they ask from us to focus not on the value of V, because we are going to use it out. They ask for the value of what? Of T. Now, by doing cross multiplication, by doing two equations with two values, okay, this equation number 1, this equation number 2, okay, you do whatever you do, okay, in math, okay, or by using calculator, you will get the answer that T will be 5 what? Seconds. If T is equal to 5 seconds, that means what? That means, okay, negative 3, that means negative 3.9 is equal to V minus 24.5 divided by 5. If we do cross multiplication, also we will find how much is the value of V that we are going to use it later on, okay, in the last part. If you please use your calculator, 3.9 times 5, okay, the answer is negative plus 24.5. How much is the answer? Give me your answer by the calculator.
بطلع 5.
بطلع ده 4
5
5 also. Okay, يعني the velocity is 5 and the time is 5. طيب. So the velocity is 5 and the speed is 5 meters per second. Okay. Now, finally, find to the nearest meter the height of the point H above the ground. To find the height, who can tell what do we need? To find the total height, what do we need? We need to find this area plus this area, which we already know it, how much? 37.75 plus this what area? We add these areas together. So the total distance is the total height. So to do this last step D, total distance is equal the area of this shape plus the area of this shape plus the area of this shape. The area of this shape is half base height, half times 2.5 times the height, which is 24.5, plus the area of this shape, which is 73.75, plus this one. Now, we know that here the time is 5 plus 2.5. That means here it's 7.5. So 20 minus 7.5 is 12.5. So here, this is 12.5 multiplied by what? 5. So 5 times 12.5. And by using calculator, the final answer, it will be 167 watt meter. Okay, let's return back here. If you please take screenshot for the first part here for part A and B. Okay, take another screenshot for part B and C together. And take screenshot for the last part D. How do we know that this is 12.5? Okay, now 20 minus 2.5 minus 5. This is 12.5, okay? Good. Any question? Okay, let's move on. Question number 8. Question number 8, what do they ask here? As you can see, inclined plane with pulley, two ideas. two particles A and B have masses of 2 kilogram and 4 kilogram respectively. The particles are connected by light and extension string. The string passes over small smooth pulley, okay, which is fixed at the top of the rough plane. Okay, the plane is inclined with a horizontal with an angle of tan alpha equal 3/5. Who can remind me tan alpha equal 3/5? What that give us?
Sine.
They give us the sine and they give us the cosine, صح? Right? So when we
Yes,
say
cosine 4/5.
tan alpha equal 3/5, that means we can have the sine alpha, which is 3/5 because of the right angle triangle, and cosine alpha equal what? 4/5. Let's continue. The particle A is held at rest, okay, on the plane with a distance of d, okay, away from what? From the pulley. The particle B is hang freely at rest. The vertical below the pulley, okay, at the distance of h meter above the ground, as shown in the figure. The particle is on the string between A and the pulley of the parallel to the greatest slope of the plane. They always tell you this information. That means we are not talking about third dimension. We are talking about 2 dimensions here. Okay, the coefficient of friction mu is what? 1/4. It's rough. That means there is a friction. The system is released from rest with a string taut and B descending. Descending, that means the acceleration is to the right or to the left. Who can tell me the acceleration to the right or the left? Tell me on the chat. The acceleration to the right or to the left? B is descending.
Right.
Exactly. The whole acceleration is to the right. That means this B accelerate downwards and this A accelerate up the plane. Okay. Now find the tension. 9 or 10 marks. 9 marks. Find the tension at B. Now to find the tension at B, we can do this in long way or we can do this in short way. I'm going to do it in long way. Okay, to let you understand the steps of doing that, okay? Step by step. Now, what do we have here? We are going to write the resultant force on B, and we are going to write the resultant force on A. Then we add them together to find how much is the acceleration. After we find how much is the acceleration, we substitute it in one of these equations to what? To find how much is the tension. But first of all, we have to know what are the forces that act on A. Okay, because we have only 2 forces that act on B. We have the weight down and the tension up. Okay, and the weight is greater than the tension. But on A, we have tension, we have friction, we have weight, we have a lot of things. So let's draw it like this. So we have, this is A. And what are the forces that act on A? We have the normal, we have the tension, and we have the weight, and we have the friction, like this. And how much is the weight? 2G, yes, 2G. Okay, these are the forces that act. And we know that we have to resolve what? We have to resolve on these axes the weight, okay? So I'll redraw it like this. Okay, so it will be in this direction, F plus 2G something, and here it will be what?
Sine alpha.
Why sine? Because the angle, bravo, the angle is what? Here, this is the angle alpha. Okay, so that means 2G sine, or I told you, whenever we slide, it's sine alpha, and here 2G what? Cosine what? Alpha, and here it's what? The normal, and here it's what? The tension, and the resultant force act upwards up the plane, so there is acceleration in this direction. Okay, that's for A. For B, okay, what do we have? We have the weight, which is 4G, and we have the tension, okay, T, and the acceleration is where? Is down, okay, like this. Now, after we do that, we have to write down the resultant force on both of them. Resultant force equal mass times acceleration, okay, and the resultant force for this particle B, okay, it's 4G minus T equal 4A, but the resultant force for A, it will be what? T minus friction
plus
minus
sine alpha.
2G sine alpha, equal what? 2A. We have two equations, and we have to know how much is the friction. So if I'm going like this, I need to continue. What is the friction here? So it will be T minus, what's the friction? Mu times R minus 2G sine alpha equal what? 2A. Now R, as you can see, it's equal to 2G cosine alpha. So T minus mu, which is 1/4, multiplied by R, which is equal to 2G cosine alpha, close the bracket, minus 2G sine alpha equal what? 2A. Now this is equation number 2, and this is equation number what? Number 1. This is the equation, the resultant force equal MA for B, and this is the equation for resultant force for whom? For A. I can make it smaller, okay? But the idea that I need to add them together. As you can see, this is negative T here, is negative, and this is positive T. If we add these two equations together, I'll get how much the acceleration. Then I'll substitute in, for example, equation number 1 to get what? The tension. Okay, so let's continue here. Okay, it will be T minus half G cosine alpha, which is 4/5, minus 2G sine alpha, which is 3/5, okay, equal 2A. This is equation number 2. And equation number 1, I can put it again, which is what here? Equation number 1, 4G, okay, is equal, okay, 4G minus T is equal to 4A. I will add them together. Add these two equations together. What will be my answer here? Okay, T with T cancel out each other. 2A and 4A, it will be 6A. Then I would say that 4G minus, okay, 4/10G minus 6/5G equal what? 6A. If you please use your calculator and tell me how much is the acceleration by using calculator. Okay, how much is the acceleration? Acceleration equal 4 times 9.
5 G.
How much? I can't hear you.
0.4.
0.4G? 0.4G.
Yes.
Okay. If it's 0.4G, 4G, then what? Then in equation number 1. So 4G minus T is equal to 4 times the acceleration, which is 0.4G. That means T equal 4G plus 1.6G, which is equal to 5.6G, which is equal to how much by using calculator? There's something wrong because they give me a different answer here. Oh, yes, it's minus. I'm sorry, minus. Okay. So minus, so it will be 2.4G, which is equal to 23.5 Newton. Okay. That's what, that's the tension. All this to get the 9 marks in part A.
So دائما 3 significant figures.
2 or 3 significant figures. You can write it here. Okay, hold on. You can write it here. Equal 24 Newton. But if they ask the value later on of G, of tension, you can write the whole thing, the whole number that you get it in the calculator. Why? Because the values will change after several steps. You keep rounding the values to significant figure, to significant. Eventually, the final answer will be different. Okay. Did I answer your question? طيب يلا. Okay. Now take screenshot for, you are welcome. Take screenshot for the steps here. Take another screenshot here. Good. Okay. Let's move on back to the other parts. This is part A now, marks. On hitting, okay, the ground, B immediately come to rest. Again, let's return back to the picture. B is going down, it hits the ground and stops. Okay, that means it accelerates by this acceleration. How much was the acceleration? It was 0.4 g. As B accelerates downwards, A accelerate upwards and have a final speed after a distance of h. Okay, it's move up the plane with the distance of h. Okay, look what they ask. Given A that come to rest before reaching the pulley, so that's what's mean. That means A, it accelerates from here to here. The distance from here to here is h. Then start to the slowing down until it stops somewhere here before the pulley. So first there was acceleration, then there was what? Deceleration, but without what? Without the tension, because the pulley, it touched the ground, the string is not taut anymore. So from here to here, there was acceleration. From here to here, there is no tension. That's why there is what? There is deceleration, okay? What do they ask? B, find in terms of h the possible range of d. Yani how far is the distance d that the particle A do not hit what? Do not hit the pulley, okay? So if this is how we are going to do, we are going to draw it in several steps. So first of all, let's draw it what's happening here. This is the inclined plane, okay? Angle alpha. A was somewhere here, and it accelerates onto the point here, covering a distance of h. Then A slows down onto the point here before what? The pulley. The total distance from here to here, where it starts, where it moves, it's d, and the distance from here to here is what? And is h. And they ask how far is the whole distance, this distance plus the distance from here to here. I'll call it s. Okay, how far is the distance? H plus s, and s it will be in terms of h. Okay, to be equal, how much is the possible range of what? Of d. Okay, now we are going to do that in two steps. First step in range of h, second step in range of fx s. So we have solved that twice, and we have a common value here. The v in the first step is u in the second step. Okay, v in the first step is u in the second step, but we have to find how much is the deceleration here without the tension. So first step, solve that. Okay, h 0, we don't know, the acceleration is 0.4 g. Okay, and we don't have t. So what do we have to do here? We have to find two things from this. We have to find the value of v. That's it. We have to find the value of v. So v square equal u square plus 2as. So v square, keep it square, okay, equal 0 square plus 2 times the acceleration, which is 0.4 g, multiplied by what? H. So it will be 0.8 g h. Okay, keep it. Then the other, so that, okay, I have it here. So that before we do it, I have to know how much is the new deceleration or acceleration. Okay, so u square is this value, okay, 0.8 g h. And this is s that we want to find it out in terms of h.
انت ما عملت سكوير روت لل 0.8 جي.
ما عملت، يس خليها. ايوه I put u square.
خلاص تمام.
u square, keep it. Okay, so before we do that, we have to find how much is the new deceleration. What is the new deceleration? Now look here. The new deceleration is the same of this equation, but without the t. Without what? The t. Okay, so what I'm going to write here, okay? It will be 4 over 10 g. Okay, hold on. 4 over 10 g minus 6 over 10 g, right? So here, half times 4 over 5 is 4 over 10 g minus 6 over 5. 6 over 5 g, okay? 6 over 5 g, okay? All this is negative. okay, equal what? The mass times the acceleration, which is 2a. 2a. Now, by using calculator, it will be 4 over 10. So it will be negative 0.8 g equal 2a. So the new deceleration equal negative 0. Or acceleration equal negative 0.4 g. Right? Okay. So that means the acceleration here is what? Negative 0.4 g. I'll use solve that again here. So v square equal u square plus 2as. V, which is 0, equal u square, which is the which is the same value of this, 0.8 gh plus 2 times negative 0.4 g. There's something wrong. I don't know what is it. Okay. Yes. Tell me.
هي مش المفروض تطلع negative 6 over 5g minus 2 over 5g.
خلينا والله نتأكد. قد ايه هاي بتطلع؟ 4 over 10 right. وهاي قد ايه بتطلع؟ 6 over 5. 6 over 5. I'm sorry. صح. 6 over 5. I put it to 2 over 5. So here 6 over 5. Yes, my mistake. شكرا لك. So 6. So it will be 12 over 10. So it will be negative. How much? 1.6. So it will be negative 0.8. Shukran. This is my mistake. So I'll put it here. So it will be negative 0. Okay. So by using calculator, move this to the other side. Negative 0.8 gh is equal to negative 1.6 gs. So divide by g by g, divide by 1.6 s, each equal to half h. So final distance, total distance, d. Okay, they ask about range, right? Or how much the maximum possible value. Stay, okay, find in terms of h the range. Okay, it's supposed to be less than 1.5, less than 1.5 what h. Why? Because the first distance is h and the second distance is half h. So that means the total distance is supposed to be, okay, more than, sorry, this d is supposed to be more than 1.5 h. Yes. It's long. Yes, I know. This is the first step. This is the second step. This is the third step. And this is the last step. Take screenshot. Yes.
مش كتير فاهمة من وين اجى ال deceleration.
The deceleration, now there is no tension, صح? Here, when B reaches the ground, the string is not taut anymore, so there is no tension. When we write the formula for the resultant force for A, ايوه احنا بلشنا هون resultant force for A، وصلنا لحد هاي الايكويشن هون، حكينا هاي ايكويشن نمبر 2. هلا بطل في تي، بنكمل هذا الحكي نيجاتيف هاف جي كله بنكمله equal 2A، فبيطلع الاكسلريشن ماله؟ بيطلع الاكسلريشن نيجاتيف. هي that means this slowing down لانه بطل في something to pull it upwards. There's no tension to pull particle A up the plane, so it starts to slow down.
Okay, thank you.
You are welcome. الله يعطيكم العافية. هيك بالضبط ساعة ونص أو حتى لسه في 4 دقائق زيادة، بس الفكرة like this we finished the whole exam in less than 1 hour and a half with discussion. Okay? Any question? Is it clear? الله يعطيكم العافية. You can stay online if you have any question. If you don't have any question, you can leave. السلام عليكم ورحمة الله وبركاته.